Welcome to the today's class. Now, in this class we are going to discuss the significance of ion characteristics in design. So, what is the role that the ion is going to play in the design of fabrics? We are going to have an idea about this aspect now. Now, most of you are already familiar with the type of ion that we have. So, if we look at this table, what we see here that the ion has been classified as span ion or filament ion. So, within span also the ion can be further classified according to fiber that has been used to produce the yarn, the preparation techniques and the spinning system that has been used to finally produce it. So, if we go by the fiber, we can say it could be pure fiber yarn in the sense that may be just one single component, that is 100% cotton yarn or 100% polyester yarn or 100% wool yarn. That is what we call pure, and blended means when we blend the two fibers together and produce the yarn. It could be 50-50 polyester cotton, it could be 50-50 polyester viscose or any other proportion that we may use it. Preparation technique wise, if we go through the span yarn route, so therefore, the two possibilities are there, one is carded, the other one is combed. And the spinning system that we choose to produce the yarns, they can also vary. It could be ring spinning, compact spinning, rotor spinning, vortex spinning, friction spinning. So, so many ways the yarn can be produced, and therefore, the characteristics of the yarn and the characteristics is reflected in the properties also will be different as we go from one spinning system to another, or we go for blended fibers, or it is a pure 100% made from pure 100% cotton fiber or viscose rayon fibers or some other fiber. The filament yarns similarly could be classified into two groups, monofilament and multifilament. And multifilament also further can be classified as shown textured, entangled or flat. Then not only that, now further we can produce different types of combination also, like we can produce compound yarns, where two different types of yarns can be combined together. Then we can have a single yarn, or we can have plied yarn also. So, the yarn can be single, 2-ply yarns, 3-ply yarns, or it could be corded also. Similarly, we can have fancy yarns, or we can have stretch yarns. We can treat the yarns by some chemicals and change these properties of the yarn. So, we can have bleached yarn, dyed yarn, mercerized yarn, degummed yarn in the case of silk. Similarly, the surface of the yarn can be treated and to give a different physical characteristics, like we can have singed yarn, we can have waxed yarn, we can have delustered yarn also. So, you see that the world of yarn is very big, and there are so many different types of yarns, and when you want to make something out of these yarns, so that could be lot of differences in the physical appearance of the fabric or the properties of the fabrics. So, as a designer you have lots of choice, and to manipulate or to engineer the properties of the final product. Now, we see what are the basic structural characteristics of these yarns. let us look at the span ions. Generally span ions will be the surface wrapping of fibers would be visible due to twist. Span ions will be variation in count and diameter. There will be some imperfections, there will be hairiness effect, and generally it will be a very high fiber packing density is also expected in span ions. So, these are the structural feature of these span ions, and the general character as a result of this is it gives a span look or a textured appearance, and the ion is generally very soft. We can have two varieties within this, carded and combed. So, carded ions are soft, warm, because they are little bulky in nature, their porosity is high in comparison to the counterpart, that is combed ions. Combed ions are generally lustrous, smoother, and they are less hairy, because generally we use low twist. So, like we have listed the different types of ion, the corresponding structural characteristics, and as a result of that, what is the general character that exists in these ions. Compact ions will be very compact in nature, that means the ion's diameter will be very low, or you can say they could be very thin for the same count. They will be strong and they are lustrous, because there are not too many hairs from the surface of the yarn. Similarly, other ions are also the type of ions, structural features and general characteristics are stated in this table. So, this is going to as a result help the designer to choose, and they can expect what type of characteristics will be there in the final fabric, and from the fabric it will make some other product. So, in the product itself, filament ions will be generally there will be very high fiber orientations, because there are no staple fibers in it. It is the very uniform, and the filament packing density is going to be quite high, but that depends upon the level of twist that you use. So, generally character wise it will be very lustrous, sheen and smooth, but it lacks in bulkiness, covering power. So, if we want to produce a fabric which is very lustrous as to be and free from surface hairs, then probably we have to go for filament ions. But if we want a intimate blending between the two types of fibers, then choosing filament ion may not be very good idea, because intimate blending between the filaments of two different types of filament ion is not going to be very successful. Then we have textured ion, and textured ion, a little diagram has been shown also. We can see that these textured ions are generally there is a high degree of fiber disorder as shown in the image itself, but generally the yarn is uniform in structure and the fiber packing is low. So, the appearance is textured, that is the filament ions which are actually very lustrous, because there is a lot of light reflection from the surface of the fiber and as well as from the yarn and fabric. To avoid that, the textured yarn is going to be helpful, because the surface fibers will be highly disoriented and there will be a lot of scattering of the light, and hence it will give a span look, and it will have a better covering power, because it is little bulky in nature in comparison to 100% filament ions, where it is not at all textured. And then we can have bulk yarn also, which is highly voluminous yarns, and these yarns also can be used in products where bulkiness of the fabric is very desirable. So, from there we go to the fancy yarn side. Now, there are so many types of, you see, fancy yarns which are produced by the industry. And so, we have slab yarns, gimp yarns, then slab and gimp combinations, loop yarns, snarl yarns, snail yarns. So, structural features and general characters are stated here. Fancy basically means they are going to affect the aesthetics aspect of the fabric. So, when we want to enhance the aesthetic aspect of a fabric or a garment, then these are the yarns to be used. So, there are so many types of fancy yarns which are also available. Next, we look at the structural characteristics of different span yarns, which are also stated in this table. The images are shown also. So, the images itself will give an idea that what we can expect if we make a fabric out of these yarns. And commercially, all these types of yarns are actually available, and the products made from ring yarn, rotor yarn, compact yarns, vortex yarns are anyway there. But if we have an idea about their structural features, the level of twist which are used in them, and the bulk or the volume aspects, then we can have an idea that what we expect in the fabric made from such yarns. So, that little details are given here. You can read yourself and find that every yarn is unique in nature, and there are certain properties in which one will be different from the other, and therefore, depending upon the type of fabric that we want to produce or the properties that we want to bring into the fabric, we can choose the right type of yarn. So, understanding about the structural characteristics is going to help in selecting the yarn for a given product. That is the idea behind giving you this table, which is a kind of comparative chart. So, one can go through it, and based on this he can decide what type of yarn we need to use for a given product. Now, the other thing about the yarn that we should know is the specification of the yarn. That suppose you as a designer, you want to finally buy some yarns from some manufacturers, some vendors. So, you must be aware about the specifications part also. So, first of all, raw material and their compositions. So, raw material could be cotton, linen, wool, silk, jute. There are so many types of fibers which are there, or it could be a blend composition, polyester cotton, polyester viscose. So, you have to specify the blend components, and also you have to specify what is the blend ratios. So, we can have binary blend as shown it here, we can have tertiary blend where there could be 3 different components also. So, different types of blend level are possible, and the manufacturers can give you yarns where that could be 2 components, 3 components, or even 4 components sometimes. Then we have to also specify about the count of the yarn, that is what is the fineness that we need, what is the level of twist that is required in case we feel that twist also could play, because you will see that later on the twist can play an important role in deciding the character of the yarn, and therefore, the character of the fabric. Uniformity level, that also should be specified, that what is the level of uniformity, tolerable level of faults in the yarn, which are imperfections, thick places, thin places. In the case of span yarns, says we cannot produce a span yarn which is free from faults. We are always trying to reduce the number of faults, but in a whenever we deal with span ions, the technology is such that we will not be able to produce a yarn which is completely fault free. There will be always some faults which is there, but we try to minimize that fault. The other important aspect is the tensile property also, that is breaking strength, breaking elongation, toughness, in some cases not always, flexibility. These are the relevant property also. Then surface integrity, that is what is the abrasion resistance, frictional coefficient or hairiness, these are related to surface integrity of the yarn. And other special specification could be whether it is a moisture management type of yarn, or you need flame retardant or resin treated or enzyme treated. So, that so many points are there based on which the yarn specification is made, or if we want to buy the yarn from a vendor, we can also specify the actual values also. But more important for us to know what is the relation between yarn parameters and fabric attributes. Fabrics are made from yarn. So, therefore, it is very natural that the yarn properties and the fabric properties, there must be some connection between them. So, the yarn parameters or yarn properties, whatever we say, or yarn characteristics like strength, elongation, yarn count, uniformity, twist, packing density, imperfections, hairiness, fiber, blend percentage. There are different types of yarn parameters or properties we can say. And now, the attributes of the fabric which are affected because of this are tensile or tear strength, texture, softness, luster, smoothness, bulkiness, aerial density. So many fabric attributes are actually affected by the various parameters of the yarn that we have listed. Hence, the kind of properties that we want to engineer into a fabric, we need to understand how or which particular parameters of the yarn is going to influence it, and accordingly we have to decide the property of the yarn. So, there is some relationship between them. Now, let us say first of all the twist, let us describe. Twist, why do you need twist? Twist is needed especially in span yarns, also the filament yarns are also twisted. Twist is a very fundamental structural parameter of a yarn. The purpose of the twist is to improve coherence between the fibers in filament yarn and also in span yarn, both. That we want to improve the cohesion. To improve coherence and strength in staple fiber yarn, that is something which is very special about the staple fiber yarn, where the fibers will simply slip from each other whenever there is a tensile load on them. So, to improve not only coherence, but the strength. So, for staple fiber yarn, coherence as well as strength both are equally important. Filament yarns, even if we do not have twist, the yarn will be strong, because there is a continuity. The filaments are not discrete members in the yarn, they are continuous in nature. But in the case of staple fiber yarn, it is made of discrete fibers. So, you have to hold the fibers together, and that holding together the fibers is because of the twist that we introduce into the yarn. The other important aspect that is affected by twist is the abrasion resistance and the fatigue behavior of the yarns. So, the see in most of the textile product will be always abraded against some other surface, external surface, or it will be abraded against itself also, or maybe sometimes it may be abraded against the human skin also, it is possible. So, abrasion is something very common, and to improve the abrasion resistance we also introduce twist into the yarn. The other aspect is fatigue resistance. There are many occasions where the yarns will be subjected to cyclic extensions, and there the fatigue sets in and the yarn fails finally. So, we need to improve the fatigue resistance, and twist has a very important role there. To enhance flexural rigidity, that is bending rigidity of the yarn, also can be influenced by twist. To make the yarn compact. So, if we want a compact yarn, we have to have a reasonable amount of twist. So, you see so many properties are actually influenced by twist. Hence, we say that twist is something which is very important, and it can completely change the character of the yarn, and therefore, can change the character of the fabric also. Next comes an idea about the influence of twist on yarn mechanical properties. So, what we see here, on sable yarn, twist will going to increase tenacity, but too much of twist is going to reduce tenacity. We will see the tenacity twist curve, it will come. Twist is going to influence the softness of the yarn, and therefore, the fabric too. Obviously, it is going to also affect the hardness, because hardness is just opposite of softness. Both of softness, hardness, tenacity are going to be affected by twist, and the filament yarn is going to affect your tenacity, the elongation, modulus, fatigue resistance, filament cohesion. So many aspects will be affected by twist. Generally, low twist leads to softer and bulkier yarn, and therefore, softer and bulkier fabric. Unbalanced twist leads to nodular effect in fabric. So, fabric appearance may get affected if the twist is not balanced. That is very important, the balancing of twist, otherwise snarling tendency will be there in the case of ply yarns, or if we over twist the yarns. Over twisting, as it is already stated, leads to rough surface effect. Surface becomes little rough, but that also is a desirable property or characteristics in some fabrics like crepe, voile, and to produce dry touch fabrics. In such cases, we over twist the yarn, and that gives a certain kind of characteristics of the fabric which people or the customers like it, and hence crepe fabrics are very popular, voiles are also very popular, dry touch type of fabrics made from cotton is also very popular. Now, this table as shown on the lower part of this now slide, it shows that how certain properties of the fabric could be affected because of twist in the yarn. Let us say crease resistance. the twist is low, it will be lower, when twist is high, it will be higher. So, crease resistance could be an interesting property of a fabric which will be affected by the twist. Air permeability also can be affected by twist, hand value, bulkiness, covering power, appearance, snagging. All these property of a fabric will be influenced by twist, and low and high twist, how they are going to affect. Let us say look at the hand value. If the twist is low, the hand is going to be soft, we will be able to produce a soft fabric, but if the twist is high, the hand is going to be harsher. So, the fabric will feel bit harsher. Therefore, crepe fabric, voile fabric, it is harsh in types of feel, but still people love it because of its very appearance and some other property of the fabric. It is a stretchable fabric, that is what it makes when the twist is more. So, there are we expect varieties of properties in a fabric, and we want the certain properties to be predominant in certain type of products, and therefore, even though in some respect the property may suffer, but in some other respect the property is something which is desirable, and therefore, we may go for high twist like in crepe fabric and voile fabric, because there are certain desirable characteristics in the fabric that we need, and that is only achievable when you go for high twist in the yarn. So, even though the hand may be harsher, still people will go for it because of these reasons. Next, this slide gives some idea about the level of twist which are used in different types of yarns. Twist is represented by twist factor. Twist factor is something which actually decides the inclination angle of the fibers in the yarn. So, the inclination angle of the fibers in the yarns are generally difficult to measure. We need a microscope, we have to fix the yarn on a glass slide and then you have to measure it. It is a very cumbersome job. But twist factor is another a numerical figure as shown is here, is basically directly connects to the inclination angle of the fibers on the surface of the yarn. What is exactly twist factors and all, that is not part of this course, but when I think you already must have learnt it when you are doing a course on either spinning of yarn or maybe yarn structure, these things are taught there in much more details. We should only know that higher the twist factor means more is the inclination of the fibers with respect to the yarn axis. So, for knitting yarn the twist factor is 3 to 3.5. These values corresponds to twist factor when the yarn count is expressed in terms of any, that is English counting system, which is very much popular in the spun yarn industry or in the cotton spinning industry, you can say. So, 3 to 3.5 is used for knitting yarn, 3.5 to 4 is used for weft yarns, 4 to 4.5 is used for warp yarns, 4.5 to 5 also can be used in warp yarns. Crepe yarn, you see the value is 5.0 to 5.5 and more than 5.5 is generally used for voile yarns. So, there is a wide range of twist which we can impart into the yarn, and it gives different types of characteristics. When the twist factor is low, the yarn will be soft and the yarn will be at the same time little weak. For knitting yarns, we do not need very strong yarns, because the stress that acts during knitting process is much less in comparison to stress which will be acting on the yarn on a loom. Therefore, we can afford to have a little less twist in the yarn that is meant to go for knitting operations. And second thing is, the knitted products are meant to be very soft, and therefore, low twist basically means the yarn is going to be soft, and therefore, the fabric also will be very soft in nature. So, many intimate garments are made from knitted products, and we need softer fabrics, and therefore, we have to go for low twist factor in the yarns. All right. From there, we move to the twist strength curve. As I said, that twist and strength of the yarn, if we see for spun yarn, how this twist strength curve looks like, that it goes up and then comes down. So, there is the optimum level of twist where we get the maximum strength. For filament yarn, the strength rises initially a little bit and then keeps on falling. So, that is the typical twist strength curve for spun yarn and for filament yarn. So, you see that initially as we go for more twist, the spun yarn strength rises because the cohesion between the fibers is going to increase, and but beyond a certain limit, the obliquity effect, that is the fibers are becoming more and more inclined with respect to the yarn axis, and therefore, the fiber strength realization in the yarn is going to fall, and that will overtake the cohesion value, and hence the spun yarn strength will be start falling down beyond this optimum twist. And for filament yarn, yes, as you go for little, say somewhere here we get the maximum strength, and beyond that the more twist we put, the strength wise the yarn will be weaker and weaker. Elongation versus twist, if we plot, generally we will get a curve like this. More is the twist, more will be the elongation part of the yarns, and so that is the typical for spun yarn, this is very common. So, how this is the twist is going to play a role. The other aspect is the fiber torsion and bending due to twisting in the yarn. Now, what happens that the individual filament path in the twisted yarn possess both torsion and curvature. So, each filament or each fiber in the twisted yarn, the fibers are subjected or filaments are subjected to torsional stress, and also there is a bending because it is following a spiral path. We are forcing the fibers to follow a spiral path by twisting it. As a result of that, what is happening? Fibers are bending and fibers are also getting certain amount of torsion with respect to their own axis. Now, this is important in certain products or in certain type of yarns. Normally, this little torsion and curvature does not matter in the case of normal spun yarns or made from either cotton or linen or wool or maybe from polyester cotton blend or polyester, this does not matter much. But in the case of yarns made from high tenacity fibers, this will have some influence. Okay, let us first see that the torsion is shown by these equations, where tau is 2 pi t cos square theta. So, theta is the inclination angle and t is the level of twist. So, for central fiber theta is 0, there is no twist into it. So, tau is equal to the inclination angle is 0. It is twisted in the sense that the torsion value of this is going to be 2 pi capital T. It is twisted on its own axis only, we can expect. Though inclination with respect to the yarn axis is going to be 0, because it is at the center part of the yarn. and the outermost filaments theta is alpha, the torsion is going to be 2 pi t cos squared alpha. So, that means the torsion value of a fiber which is on the surface of the yarn is less in comparison to the filament which is, or the fiber which is at the center point, that will have maximum torsion. So, torsional deformation will be maximum for the central fiber and it will be minimum for the fiber which will be at the surface of the yarn. And if you look at the bending curvature given by these equations, and for the central fiber theta is 0 and therefore, C is 0, it has no bending because it is at the center part of the yarn. So, there is no bending at all, but for the outermost fiber on the surface of the yarn, the C is going to be pi sin 2 alpha by h. So, these standard equations are available in the textbooks on yarn structures. So, we are not going to derive this, just we have taken the final equation just to know that what is going to happen. If the torsion is maximum for the central fiber, so the fibers which are weak to torsional stresses like glass fiber. Now, in the technical yarns like made from glass fibers, it could be made from carbon fibers, it could be made from high density polyethylene fibers. These fibers are high performance fibers, and generally these fibers are, they have been found to be sometimes weak with respect to their shear strength. So, when these fibers, suppose a yarn made from these fibers are twisted too much, torsion is going to, center filament will be extended, torsion is going to go beyond the critical value, and therefore, there could be some amount of damage into these filaments. Generally, you will find that yarns made from high tenacity fibers are not twisted much. They are given only very little twist, not much twist. The purpose of giving twist to these yarns is just to hold the fibers together, so that they do not spread out. So, just to avoid this spreading, we put only a little bit of twist, but we do not put too much of twist, because by doing so we will be actually weakening the yarn as a whole, because we will force the fibers to follow bending path, and the fibers will also be subjected to torsional stresses, which is may affect their property. Here certain formulas are stated, many of you may be knowing it already. So, but to a designer these formulas should be available with him, so that they are handy and they can use it just to do certain calculations which may be required. So, diameter, yarn diameter as shown it here, yarn specific volume is also given here, packing coefficient, surface twist angle, all these things are stated. Now, yarn cross sectional shapes within the fabric is shown here, and on the left hand side table shows packing coefficient in yarn. This is something which is also important for us, because how the fibers are packed in a yarn can also affect the properties of the yarn and also the properties of the fabric. So, generally the type of packing coefficient that we expect in multifilament yarns, untwisted or very little producer twist, it will give you a packing coefficient 0.25, regularly twisted 0.60, very hard twisted may give you around 0.9. That is the maximum packing that we can expect when the fibers are circular in nature. And staple yarns, soft twisted packing is going to be 0.33, 0.60, something like as it is stated here. These are the values for different types of staple fiber yarn. So, packing coefficient in a way indicates the proportion of space occupied by the fibers. That is what is packing. In a given volume of fibers, a given volume of yarn, how much volume is occupied by fiber, that is what is the packing coefficient of the yarn. And the same can be extended to fabric also, that in a given volume of fabric, how much is occupied by the fibers, rest is occupied by void. Anyway, so packings, typical packing values are stated here, and the right hand side I show you some interesting picture that gives you the deformation of the yarns within the fabric. 4 diagrams are here, or 4 images are here. This is for low twist, this is for high twist, and these 2 are for intermediate level of twist. This has been done, these images are for filament yarn, and we see that the image which is elliptical here, when the twist is low, like this one, and here it is becoming almost circular, the twist is high. So, the level of deformation the yarn is going to experience when they are actually within the fabric depends upon how much twist was inserted into the yarn. And the deformations is quantified by the term called ellipticity. So, ellipticity ratio generally varies from 0.35 to 0.86 as has been stated in this research paper. So, that is typical values which we can expect in filament yarn when it is within the fabric. And why the deformation is happening? Because at the interlacement point there are a lot of forces which are acting, and because of these forces at the interlacement point both the yarns are basically pressing each other. As a result, if the yarn is circular in nature, it is going to be deformed and it is going to take a shape which is close to an ellipse. So, how much it will be deformed depends upon what is the level of packing in these yarns. Packing in terms depends upon how much twist was inserted into the yarn. And you see, therefore, the property of the fabric, especially the thickness value of the fabric, is a function of the deformation in these yarns within the fabric, which in turn depends upon the packing coefficient of the yarn. Packing coefficient in turn depends upon the level of twist that we have chosen in these yarns. So, this is how the twist becomes important. And the other thing which will be important for us to know is that how much fiber strength is translated into yarn strength. Now, fiber to yarn strength translation efficiency, some values are quoted here. For multi-filament yarns, the values are quite high. Untwisted yarns, it is almost 98%, and the unit is going to be in percentage. Slightly twisted yarn 95%, air jet textured yarn 85%, but for spun yarns is generally low. Soft twisted yarn 45%, hard twisted yarn it is 67%. So, that gives you an idea that how much strength of the fibers you can expect to be translated into the yarn. So, and this information can help us to decide that for a given yarn strength what should be the fiber strength. The yarn counts which are generally used for different types of products are different. So, some products and corresponding count range which are used to produce them is stated in this particular table. For drills, this is the typical count. So, count range, this is the unit is any lungi, bedspread, blended shorting, cotton cloth, shoelace, different types of products. Names are here on the left hand side, right hand side gives you the range of counts which are used to produce them. So, this is something which will be useful from the point of view of design a particular type of cloth or particular type of product. Suppose I want to produce a wiping cloth, I must know generally what type of yarn counts are used to produce them. Okay. From there we go to the next technical products that we can make from monofilament yarn. See, monofilaments means that says only single filament. Monofilament results in better abrasion resistance than multifilament yarn, better fatigue resistance, and it has a well defined inter yarn pore when it is in the fabric form. So, here also some products are stated, type of fibers which are used is also given, and the typical fiber diameters or filament diameters which are used. So, conveyor for paper making machines, fibers used are, so this is the requirement is temperature resistance, dimensional stability and abrasion resistance are very important. This is a technical product. Fiber used are polyester, polypropylene sulfide, polyphenylene sulfide. So, polyether ether ketone, nylon. So, these are the fibers which are used, and typical filament diameters are also stated. So, one side product, typical requirements, fiber to be used for them, and the filament fineness in terms of their diameter is stated here. So, this is what is these products are made from monofilament. Similarly, we can make products from multifilament yarns also, some typical technical products like seat belt, airbag, sailcloth, cut resistance fabric, safety belts are all stated here, and the requirement is stated also. One column, typical fibers to be used also stated, and their linear densities are also stated here. So, what we see here that there are certain products where monofilaments are useful, there are certain products where multifilaments are useful, and there are certain products where we have to go for staple fiber yarn. Okay. From there we go to the next slide, and that is all about paying your attention to this particular lecture. So, we have discussed the different types of yarns that we use. So, what are the general characteristics and how they can influence the property of the fabric, and one of the most important yarn parameter is the twist and the role of twist in deciding different properties of the fabric. And this kind of information is important because that is what is going to help the designer in choosing the right type of yarn. Thank you.